Applications with motion. Motion problems can be used to study a lot of realistic situations. You just need to know distance equals rate or speed times time. We've talked about that before, and we've talked about the fact that you already know that. If you're going 60 miles per hour, that's a rate or a speed, and you drive 60 miles per hour for 2 hours, you know that you've gone 120 miles. So distance equals rate times time. Dirt. If you have to drive 50 miles an hour for 5 hours, how far will you go? 50 miles an hour times 5 hours. Notice that the hours cancel. You're left with miles, so you get 250 miles. When you're working word problems using distance, rate, and time, it is usually very helpful to organize your information into the following table. So we have two situations, and we want the distance, rate, and time about both of those situations. The diagram is helpful. So example 9, airplane travel. A private airplane leaves an airport and flies due south at 192 miles per hour. 2 hours later, a jet leaves the same airport and flies due south at 960 miles per hour. When will the jet overtake the plane? So the distance that they both travel is the same, so we'll use the variable d to represent that distance. We know the rate of the private plane is 192. The rate of the jet, what's that? 960. What about the time? If we let x represent the time of the private plane, the jet leaves 2 hours later, so its time will be x minus 2. We know that distance is rate times time, so we get two equations from this. We get the equation of the private plane, distance equals rate times time, and we also get an equation from the jet, distance equals rate times time. D equals 192x. D equals 960 times x minus 2. Now notice that these distances are the same. D equals 192x. We can substitute 192x into the second equation in place of D. So we have 192x equals 960. Let's go ahead and multiply that out. X minus 1920. We need to solve for x. Let's subtract 960x from both sides. That gives us negative 768x equals negative 1920. We want to solve for x, so let's divide both sides by negative 768. That gives us x equals 2.5. X is the time that the private plane flies. When will the jet overtake the plane? Well, this is the time, it's hours. We want to know how long the jet, that's the time of the private plane. We really want to know how long the jet will be in the air. What's the time of the jet? So that's x minus 2. 2.5 minus 2. That's just in 0.5 hours. So the jet will overtake the plane in 1/2 hour. with and against the wind. An airplane flew for 4 hours with a 20 kilometer per hour tailwind. The return flight against the wind took 5 hours. So the time flying against the wind is 5 hours. Notice that we have a rate r minus 20 if we're flying against the wind. That's because that wind is pushing back against us. So whatever rate we normally would be going, we subtract 20. On our trip there, we're flying with the wind. So what's the rate when we're flying with the wind? R plus 20. That 20 kilometer per hour tailwind is pushing us faster than we normally would go. And we have 2 lines, 2 equations. Distance equals rate times time. Distance equals rate times time. So that gives us distance. Let's multiply through, get rid of those parentheses, equals 4r plus 80 from our first row. From our second row, we get distance equals, multiplying through, 5r minus 100. We traveled the same distance regardless. D is 4r plus 80. Let's substitute that into the second equation. So we get 4r plus 80 equals 5r minus 100. Subtract 4r from both sides. Add 100 to both sides. We get 180 equals r. Find the speed of the plane in still air. That's r. R is our speed. And since the wind is in kilometers per hour, the plane's speed should also be in kilometers per hour. 180 kilometers per hour. That's our answer. A student walks and jogs to college each day. She averages 5 kilometers per hour walking. That's a rate. So we want to put 5 for her walking rate. 9 kilometers per hour jogging. That's her rate to be jogging. The distance from home to college is 8 kilometers. She makes the trip in 1 hour. So the total distance, she's walking and jogging on her way to college. We don't really know how much of the time she spends walking and how much of the time she spends jogging. But we know that the total distance, we need a third line for our table here. Our total distance is 8 kilometers. The trip, the total time, is 1 hour. So how far does the student jog? That's what we want to know. What is the distance that the student jogs? Well, let's let x be the distance that she jogs. How much time does she spend jogging? I don't know. Let's call it t. So, if the total distance to school is 8 kilometers, and she spends x of them jogging, how many kilometers does she walk? 8 minus x. If t is the amount of time she spends jogging, and she takes a whole 1 hour to make the trip, how much time is left for walking? 1 minus t. And we know that distance is rate times time. Distance is rate times time. And we really want to solve this equation for x because it says how far does the student jog, and that's what x is. So we get 8 minus x equals, let's multiply that out, 5 minus 5t. That's our first equation. And x equals 9t. You might be tempted, let's go ahead and do it. You Let's substitute 9t into the first equation in place of x. So that gives us 8 minus 9t equals 5 minus 5t. So let's add 9t to both sides. And while we're at it, we can subtract 5 from both sides. And that will give us 3 equals 4t. Divide by 4, and 3/4 equals t. 3/4 of an hour is the time that she spends jogging. But we want to know how far does the student jog. We want to know what x is. Well, looking back at our equations, we see that x is 9t. So x is 9 times 3/4. X is 9 times 3/4 is 6.7 miles, 6.75. And are these miles? No, these are kilometers. So how far does she jog? She jogs 6.75 kilometers. Notice we solved for t, but that wasn't what we really wanted to know. But we could use that t value, that 3/4 of an hour, to find x, how far the student jogged. That's what we really wanted to know. The Nature Center sold 75 bags of birdseed. One kind is $6.50 per bag and the other at $8.95 per bag. In all, $573.25 was taken in for the bags. How many bags of each kind were sold? So we have two different kinds of bird feed. Let's let x stand for the number of 650 bags. Let's let y stand for the number of 895 bags. Now we know that there's a total of 75 bags. So x plus y equals 75. We know that we're going to take in $573.25 after we sell all these bags of birdseed. So we're going to get $6.50 for each x bag, and we're going to get $8.95 for each y bag. That gives us two equations. That's our system of equations. We need to solve for x and y this time. We can do it by substitution or elimination. I'm going to do it by elimination this time. I have 650x, so I wish that my first equation had negative 650x. So I'm going to multiply the first equation by negative 650. Negative 650x minus 650y equals, we need to multiply negative 650 times $75. Negative 487.50. So when we add those two equations together, the x's are eliminated. We get 895 minus 650. That gives us 245y. We have 573.25 minus 487.5. That gives us 85.75. Let's divide both sides by 245. And we get y equals 35. We're going to sell 35 bags of the $8.95 birdseed. We know that x plus y is 75, and since y is 35, how many bags of 650 birdseed do we sell? 40. So we sell 40 bags at $6.50 and 35 bags at $8.95. And that's our answer. A rectangle has a perimeter of 100 feet. The length exceeds the width by 30 feet. Find the length and the width. We can draw a picture of the rectangle. It has two dimensions, length and width, and the length exceeds the width by 30 feet. We know that the perimeter of a rectangle is twice the length plus twice the width. It's just the distance around the outside of the rectangle. The perimeter is 100. The length is W plus 30. And the width is W. So we have 100 equals 2W plus 60 plus 2W. Subtract 60 from both sides and we get 40 equals 4W. Divide by 4, W is 10. If W is 10, what is the length? 10 plus 30, that's 40. So this perimeter is 40 feet by 10 feet. And that's the answer. One day Joe purchased 2 burgers and 2 fries for $8.30. The next week, Joe purchased 3 burgers and 4 fries for $11.65. What is the cost of a burger and the cost of a fry? Well, let's see. He purchased 2 burgers and 3 fries for $8.30. The next week, he purchased 3 burgers and 4 fries for $11.65. Looks to me like an elimination sort of problem. Do we want to get rid of burgers or fries? Doesn't matter. I say let's get rid of the burgers. We have 2 burgers and 3 burgers. We would like for those coefficients to be opposites. 2 and 3, the least common multiple of 2 and 3. The smallest number that 2 and 3 will divide into evenly is 6. So if we multiply the first equation by 3, that'll give us 6b. And if we multiply the second equation by -2, that will give us -6b. So they'll be opposites. So that gives us 6b plus 9f equals, we have to multiply 8.30 times 3. 2490. Then we're going to take the second equation, multiply it by -2, so we have -6b minus 8f $11.65 times a -2 -23.3. The b's cancel. We wind up with just one f, which is really nice. And what's 24.90 minus 23.30? $1.60. Fries are $1.60. How much are the burgers? Go to either one of the original two equations. The first one is 2 burgers plus 3 fries, but we now know that fries are $1.60 equals $8.30. So 3 times $1.60, $4.80. Let's subtract that $4.80 from both sides. So $8.30 minus $4.80, $3.50. We have to divide that $3.50 by 2, and we get $1.75. So the burger is $1.75, and the fries are $1.60. The burger cost $1.75, and the fries cost $1.60. And that's our answer. Supplementary angles are angles whose sum is 180 degrees. Two supplementary angles are such that one angle is 3 times the other. Find the measures of the angles. So we need a way to variables for these angles. Let's use x and y. Why not? Their sum is 180. And one of them is 3 times the other. Oh, what do you want to use? Substitution or elimination? This problem just screams substitution for me, because x is 3y. So why not put that into the first equation, and we'll get 3y plus y equals 180. We'll get 4y equals 180. Divide both sides by 4. We get 45. Y equals 45. If y is 45, what's x? Well, we know x is 3y. And since y is 45, what is 3 times 45? 135. Find the measures of the angle. The angles, they are 45 degrees and 135 degrees. And that's our answer. A plane flying with the wind traveled 900 miles in 3 hours. The return trip traveling against the wind took 4.5 hours. Find the speed of the wind and the speed of the plane in still air. So we need the speed of the wind and the speed of the plane in still air. Distance, rate, and time. We have 2 situations here. We have with the wind and against the wind. It traveled 900 miles going both directions. So the distance is 900 miles in 3 hours. The return trip, which is also 900 miles, traveling against the wind took 4.5 hours. We want to know what is the speed of the wind and the speed of the plane. So let's let P be the speed of the plane. If the plane is flying with the wind, and W is the speed of the wind, if the plane is flying with the wind, that wind is making it go faster. It's pushing it along. So we'll add their speeds. But against the wind, that wind is fighting against the plane. So it's P minus W. We know that distance is rate times time. So that gives us 900 equals, I'm going to put that 3 first, and then the p plus w, or 900 is 4.5 times p minus w. So our first equation, let's get rid of the parentheses, 900 equals 3p plus 3w. The second equation, 900 equals 4.5p minus 4.5w. Substitution or elimination? I don't know, I don't think it matters, but I'm tempted to use elimination. We have 3 and we have 4.5. I changed my mind. I don't know, it really doesn't matter, but I think what I'm going to do is solve the first equation for p. So if we have 900 minus 3w equals 3p, and then we divide both sides by 3, that will give us 300 minus w equals p. So let's try that. 300 minus w equals p. We're going to substitute this into the other equation in place of p. So 900 equals 4.5 times 300 minus w minus 4.5 w. 900 equals 4.5 times 300, 1350, minus 4.5w minus 4.5w. Let's combine our like terms. Let's subtract the 1350 from both sides. 900 minus 1350, negative 450, equals negative 9w. Divide both sides by negative 9, and we get 50, positive 50 equals w. That's a 50-mile-an-hour wind. That's a pretty good wind. What is the plane, the speed of the plane? We know it's 300 minus w. And now we know that the wind is 50. So that plane must be flying at 250 miles per hour. Let's go back and check the question. Find the speed of the wind and the speed of the plane. Miles and hours. The wind is 50 miles an hour, and the plane flies at 250 miles an hour. And that's our answer. That's all for this section.